All right, this is APBC Calculus. We're doing midterm review, and this is free response 20D, which is non-calculator. So on this axes provided, and that's my bad because I forgot to provide the axes in your review packet, but on the axes, sketch a graph of G on the closed interval from -2 to 2. So here's the thing. I know a few things, okay? So the first thing I know is that when the bounds of an integral are the same, the area inside that integral is 0, right? So g of 0 definitely has to be 0, right? But I also know that g of 2 is going to be 0 and g of -2 is going to be 0. And here's why I say that. This area offsets this area. So g of 2 is also going to be 0 because anything I gain up here, I lose down here. And the same argument going this way. This area offsets this area, so g of -2 is also going to be 0. So when I sketch a graph, I know some things. So here's my -2 and my +2. I know that g of -2 is 0. I know that g of 0 is 0, and I know that g of 2 is 0. Let's talk about what else I know. I know that on this entire interval, f has to be, g, which is, so f prime is the same, g prime is the same as f, right? So g prime, which is the same as f, is greater than 0, meaning that g is increasing. So basically, on the window from here to here, my function has to be going uphill, right? Like g is increasing on this window from here to here, right? I know that down here in purple, down here, g prime, which is f, is less than 0, so g has to be decreasing, meaning that over here, g has to be decreasing, and over here, g has to be decreasing. So g is decreasing here in this window, and g is decreasing here, right? So like it has to be going downhill, downhill. In the middle, in this green spot, it had to be going up. So it looks like this zigzag. And then for concavity, and this is the part that I think always gets people a little bit. So wherever this slope is positive, right? So f double prime, right? So which is the same as, hang on, I mean f prime, my bad, reversed functions. It's been a long day. G double prime, which is the same as f prime, is going to be the slope of this thing. So this is where g double prime is positive, meaning that in this entire window, we have to be concave up. So g has to be concave up, meaning that it's decreasing but cupping upward like this. And then in this entire window, g has to be concave down because over here, g double prime, which is the same as f prime, is less than 0. So on this side, we're concave down, and that kind of fits with what I'm looking at. So again, I'm increasing to decreasing, and my graph comes out something like this. So basically, I don't even care what the other y-values are. I didn't even scale my y-axis. There was no point in scaling my y-axis. I know for sure that these 3 points have to be 0. I know that I have to go from decreasing to increasing, and increasing to decreasing. I know that I have to be concave up on the interval to the left of the y-axis and concave down on the interval to the right, and there's my graph. And that's kind of the gist of it. Another way to do this is you can kind of break it into little segments. I'm just going to add down at the bottom, I'm going to show you another way to do this is to physically look at this like it's little segments where I know these 3 points, right? We figured out these 3 points. And then I can kind of break each chunk into a little piece, and I can look each piece whether I should be increasing or decreasing, and whether, so we already established that since my function, which is the same as g prime, is below the x-axis, I should be decreasing, increasing, increasing, decreasing. And then for concavity, we established that I should be concave up, concave down, and then when you sketch your graph, you can do that where you do down, up, down, and then you round it out. So cup upwards, keep cupping upwards, cup downwards, keep cupping downwards, right? And that's kind of the gist of it. I should have horizontal tangent lines at 1 and -1, and that makes sense because if you look up here, my derivative, g prime, is 0 here and here, so I should have a horizontal tangent line here and here, right? And that's the same thing if I drew the graph this way down here. So same graph, basic idea. There's no real reason to scale the y-axis.